problems involving partial fraction. My third rule is this: when the factors of the denominator are in the form ax squared plus bx plus c, obviously this is quadratic. So when the roots of the equation of the denominator are in the form ax squared plus bx plus c, where this becomes a non-factorizable quadratic equation, then the partial fraction comes in the form ax plus b all over ax squared plus bx plus c. So this becomes the form for a partial fraction where the denominator is quadratic and at the same time is non-factorizable. I'll have this form. Let's have an example and explain this. Example, please take that. Resolve into partial fraction. Resolve into partial fraction Alright, so resolve into partial fraction this one. Alright, so my first task here is to consider denominator as usual. So this will now give you something about x power 4 plus x cubed plus 2x squared. Now usually what you should use here should be what we call the polynomial concept, testing for roots. Put x as 1, x as minus 1, and each one gives you 0. But then once again, if you look at it very well, something is common within all three. True of us. What's common here? X. X. What's common here? All of them has x squared. True of us. Yes. Yes. I can divide here by x squared, divide here by x squared, divide here by x squared. In this case now, this cancels this. I'm left with what? 2. This cancels. I'm left with what there? X. This cancels. What do you have there? That means if I have x power 4 plus x power 3 plus 2x squared, this can be written as equal to, I can have, so I see here, x squared. So x squared into x squared plus x plus 2 into x squared plus x plus 2. So this answer is the same thing. This time this gives you x power 4. This time this x cubed. This time this 2x squared. You have to open your eyes very well. So I have this one. So I have this now. Next up, this one here. Please, on your own, please give me roots, please. Give me the form on your own, please. What do you get? Let's get this done, please. So, attach now to find the form of this. From here, we'll have that x squared plus 2x plus 3 all over x to the power 4 plus x cubed plus 2x squared is equal to, now you observe we are having x squared. X squared falls under root 2, which is a repeated root. So my form becomes, first of all, a over x plus b all over x squared. This concept is from root 2, when we dealt with repeated roots. Next up, I have this one here. Now, this one here is a non-factorizable quadratic equation because there are no two possible numbers that if I add them, I'll have 1 and multiply them will give me 2. They don't exist. So it becomes a non-factorizable quadratic equation. So it becomes plus. Now we said for non-factorizable quadratic equation, I should be having ax plus b all over that equation. I should have this one here. But the fact is this, a and b has already been taken as a and b. So if I'm taking a and b, I'm left with what? C and d. So it becomes cx plus d. I'm having here as cx plus d all over what I have here, x squared plus x plus 2. Alright, so I have it. This becomes the form of that partial fraction. Next up, I'll have to take LCM. So taking the lowest common multiple. What's LCM? I should do that Juju Fernandez something here. Look at my phone. See what's LCM? The Lucifer. Take LCM. What's LCM, man? From here it comes what come here? X squared plus 2x plus 3 all over x over 4 plus x over 3 plus 2x squared is equal to, for this one, take LCM. We've said when it comes to repeated roots, for these two, the LCM becomes this one here, with the highest part. So that before. It becomes this one here, x squared into this one here. I'm having x squared plus x plus 2. So I have it. Alright, for spacing, let me clean this stuff here. Alright, this becomes, look at it. If I divide this with this, 1x will cancel 1x here. So I'm left with x and this. Use to multiply a becomes a into x into what there? X squared plus x plus 2. So I have this. Alright. Divide this by this. 1x will cancel 1x here. So I'm left with x into this. That's this. Multiplies a plus, for b, x squared will cancel x squared. I'm left with this one here. Use to multiply b becomes b into x squared plus x plus 2. I have this. So plus this divide this, I'm left with x squared. So it becomes in bracket cx plus d multiplying, if this divides this, I'm left with x squared. So multiplying x squared. So cx plus d all into x squared. So I have this. So at this point here, next up, equating numerator. What do I get? Here gives me x squared plus 2x plus 3 is equal to, work this out, this gives you a into expand this, that gives you x cubed plus this and this, x squared plus x times 2x plus b into x squared plus x plus 2 plus, in bracket, cx plus d into x squared. So I have this one here. My next task will be to expand this one. If I expand this, it gives you that, or have that x squared plus 2x plus 3 plus 2x plus 3 is equal to, expand this one here, a times x cubed is a x cubed, a times x squared gives you ax squared, a times 2x, 2ax, b times x squared, bx squared, b times x, bx, b times 2, 2b, plus cx times x squared, cx cubed, plus z times x squared, dx squared. So this becomes my result on expansion. Next up, I'll have to factorize this. Alright, so let's factorize this. So factorizing, I have that x squared plus 2x plus 3 is equal to, start with the ones with x cubed, that becomes ax cubed and cx cubed. That becomes ax cubed plus cx cubed. Take up the x squared. That gives you ax squared plus bx squared plus dx squared. So plus I have ax squared plus bx squared plus dx squared. I'm done with x squared. Take the ones with x. That becomes this one here. This one here. That's all. Yes. 2ax and bx. That gives you plus 2ax plus bx. Lastly, take constant. What are the constants here? 2. Just 2b. Yes. Alright. So I have plus perhaps here. 2b as the constant term. Alright, so I have this now. Next up, what's factorizing? That's collecting like terms, right? So this should be collecting like terms. So I'll be collecting like terms. Collect like terms. Next up, let's now factorize. Factorizing, what do I get here? This gives you x squared plus 2x plus 3 is equal to, get out x cubed, and left what there? A plus c. We have a plus c all into x cubed. For x squared, take out x squared here, you have a, x squared here, you have b, x squared here, you have d. That gives you a plus b plus d all into x squared. Get down the x plus, take out x here, you have 2a, take out x here, you have b. So plus 2a plus b all into x. Finally, plus 2b. I have this. Alright, at this point now, you can see comparing coefficients. The highest coefficient here is x cubed. So you say for x cubed, there is no x cubed there here. So I have 0 is equal to x cubed. Coefficient here is a plus c. Call this equation 1. Next up, for x squared, if I work out x squared, coefficient here is 1. So I have 1 equal to x squared. I have all of this. A plus b plus d. Call this equation 2. Next up, for x, work out coefficient. For x, coefficient here is 2. So 2 is equal to, work out coefficients here. That's what that 2a plus b. I'm having 2a plus b. Call this equation 3. Finally, for constant. So my constant term, what I have here is 3. So 3 is equal to, my constant here is 2b. So I have 2b. Call equation what there? 4. So I have equation 1, 2, 3, and 4. So we have to get the value of a, b, c, d from these 4 equations. Alright, so from equation 1, 2, 3, 4, the easiest to solve here is this one here. From this I can easily get b. So from 4, divide this to 2. So from equation 4, it's clear that we said 3 is equal to 2b. To get b, divide by 2, divide by 2. This cancels this. So we have that b is equal to 3 over 2. I've gotten b. The next task, we put b here. So I'll get a. So put b equal to 3 over 2 into this one, yeah? Into equation 3. And that will give me, we said 2 minus 2 is equal to 2a plus b. Let's get a here. If I move b over here, I'll have 2 minus b is equal to 2a. Put the value of b as 3 over 2. 2 minus 3 over 2 is equal to 2a. Work this one out. This will give you 1 over 2 is equal to 2a. So get a here. What do you do now? Divide by 2. If I divide by 2, or you can say multiply by 1 over 2, whichever one works. So I can say multiply both sides by 1 over 2. Multiply this by 1 over 2. Also multiply here by 1 over 2. Multiply both sides by 1 over 2. I'll have 1 over 4 is equal to this, will cancel this, a. That means I've gotten b as 3 over 2. I've gotten a as 1 over 4. Next up, depends on which you want to start with. You can start with c. To get c here, it's easy enough. From equation 1, I have that 0 is equal to a plus c. So let's get c. I'll do this one over here. I'll have minus a is equal to c. We already have a as 1 over 4. So I have that minus a is 1 over 4 is equal to c. So I've got the value of b, 3 over 2, a, 1 over 4, c, minus 1 over 4. Let's now get z. So I'll put the value of a and b here to get z. So put a and b into equation 2. I'll put a, which is 1 over 4, and b, which is 3 over 2, into this one here, into equation 2. So we said 1 is equal to a plus b plus d. Alright, include values. Alright, put the value of a and b here. I'll have 1 is equal to a. A is what? 1 over 4. So 1 over 4 plus b. B is 3 over 2. So 3 over 2 plus d. I have this. So 1 is equal to, work these two out. My LCM is 4. Alright. 4 over 4 is 1 times 1. 1 plus 4 over 2 is 2 times 3. That's 6 plus d. So I work out these two fractions. I'll have this one here. I'm not having 1 being equal to, this gives you 7 over 4 plus d. Move this over here. 1 minus 7 over 4 is equal to d. Work this out, this gives you minus 3 over 4 equal to d. So I've got the value of a, b, c, and d. So therefore, I have that a is equal to 1 over 4, b is equal to 3 over 2, c is equal to minus 1 over 4, and d is equal to minus 3 over 4. Alright, let's include this back into our general form and then see our answer. X squared plus plus 2x plus 3 all over x power 4 plus x cubed plus 2x squared. It was equal to a, abi? What was a there? Okay, what does it was? It was equal to a all over x plus b all over x squared plus cx plus d, cx plus d all over x squared plus x plus 2. So please input values. This will now be equal to a is 1 over 4 all over x, so a over x plus b is 3 over 2, so 3 over 2 all over x squared plus cx, this is c, minus 1 over 4x cx plus d, d is minus 3 over 4 all over this one here. So this gives you cx plus d into x squared plus x plus 2. Simplify this one further. Just take it in bits. This will give you 1 over 4 to x plus, this will give you 3 over 2 to x squared. These two are having the same denominator. Now, hold on. First things first, same denominator, so it will be all over 4. So what next? Minus 1 times x gives you minus x, plus minus 3 gives you minus 3. So I have this one here. So I'm having this all over 1 there. X squared plus x plus 2. Look at this. I'll put this one here and factorize it outside. I'm seeing negative inside. Bring it outside here. Bring it outside here. So this will now be equal to final answer. This will now be equal to, we set this one constant, 1 all over, multiply this to 4x, okay, plus, keep this one there, 3 all over, multiply this one here, 2x squared. So we said minus will come outside here. Since minus come on here, minus will come outside here, becomes plus minus. That's minus. If minus comes out here, it becomes what there? Positive and positive. So it becomes plus 3, x plus 3, this one here, all over, this one multiplies this, 4 into x squared plus x plus 2. Here is this 3. I'm having minus x minus 3 over 4. Take out the minus. If minus comes out, it becomes x plus 3 over 4. Minus times x minus x minus times plus 3 minus 3 over 4. So this is this. So we said keep this one up. So this minus comes here. So minus plus gives you minus. Keep this one at numerator. Then multiply this and the lower one. This and this. You get this. This now becomes your answer. So you have this one here. This is how you solve this question.